All right, we're going to continue with the rest of the examples for choosing a method. If you didn't watch the first video, I'll definitely go back and do that where we go over the different strategies that you can use. Okay, so let's pick right back up where we left off. I'm not necessarily going to finish all of these. We'll kind of see how it goes. So for number 5, does this fit a basic integration rule? No. Number 2, can we rewrite it using algebra? Maybe. The big clue on this one is we are dividing by a monomial. So that means we can divide this out. You can do it one of two ways. You can rewrite it as e to the negative x and use multiplication, or you could rewrite it as division with a common denominator. So we'd have e to the 2x divided by e to the x minus 1 divided by e to the x. As long as you keep the denominator the same, that is equivalent, okay? Now, when we divide e to the 2x divided by e to the x, that's just e to the x. And then this one is e to the negative x dx, okay? Now, notice this now has to be broken into two different strategies because this first e to the x, that's just a basic integration rule, e to the x dx. This one has a exponent that's been changed. So this one is going to require u substitution. So that's why we want to treat this as two separate integrals. For the second one now, we want to let u equal negative x. That means du equals negative dx. So this gives us now, this integral was already negative, so now it's going to be positive e to the u du. And so what we get then is we're ready to do, well, this is going to come out to e to the u. So if we look at the two pieces, this first integral is going to give us e to the x, plus this second one, e to the u, is going to give us e to the negative x, and then we have plus c. So that's the answer there, okay? You cannot use a log rule here. You cannot take the integral of all three pieces separately. That's never allowed. Okay, so that's where we want to start. Number 6, first question is always, does this match a basic integration rule? Well, by itself, both of those terms, sine x minus sine squared x or secant squared x, no. But if I split it up, each of these on their own is a basic integration rule. The antiderivative of sine of x is negative cosine of x. And the antiderivative of secant squared is tangent of x. The derivative of tangent is secant of x. So that's it for that one. It's a basic integration rule. All right. All right, if we look at number 7, cosine of x times tangent of x on its own is not a basic rule. But would it be possible to rewrite this? Maybe, because I know that tangent of x is equal to sine of x over the cosine of x. Now the cosines cancel out, and all we're left with is the integral of sine of x dx. Now that's an easy one to do. That just gives us negative cosine of x plus c. So that one does end up being a basic integration rule when we go ahead and use that identity to do some rewriting. All right, number 8, we have the integral of 20x cubed over the square root of 25 minus 25x to the 8th. Not a basic rule, can't be rewritten. Now the question is this an inverse trig rule? That's always a great thing to check first. And it's hard to tell, but we could check if it was, this would be a squared minus u squared. So that would mean that a is equal to 5. The perfect squares are a good clue here. And u would be equal to 5x to the 4th. that would make du equal to 20x to the third dx. And what do you know? That is exactly what we have. So this one is going to be, in this case, arcsine, because it's constants minus variables. So this is going to come out to the arcsine of u over a. So that's 5x to the fourth over 5 plus c. And those 5's cancel out. So we just get arcsine of x to the fourth plus c. So that one ended up being pretty easy. It looks really gross at the beginning. Not too bad. Okay, number 9. Can we simplify this? It's not a basic rule. We cannot simplify. We can't divide by that denominator because it's more than one term. We can't break apart a denominator, only a numerator. And so there's not a real clear inside and outside, like with a power or a square root. So we probably are going to want to do u substitution here. This doesn't look like it's going to match a trig rule. So if we do u substitution going down that checklist, there's no real inside outside. There's no exponential term. We have exponents, but they're not exponential. So that means that u substitution and letting u be the whole denominator is probably our best bet. So u is equal to x cubed plus 2. That means du is 3x squared dx. Now, this is another weird one where we don't have the 3 just on its own, but we do have 12, and 12 is 4 times 3x squared. So we don't need to do any adjusting. We already have it. We can just pull the 4 to the front of the integral. So we get 4 times 1 over u du. So that's going to be 4 times the natural log of the absolute value of u plus c. Again, if this had like a squared on it, that's not a log rule. Okay, log rule is only u to the first. But now that we have that, the answer is 4 times the natural log of the absolute value of x cubed plus 2 plus c. There's no guarantee that that's positive, so we need to leave the absolute value there. Okay, number 10. Number 10, clearly not a basic rule. We can't really rewrite that. We've got exponentials mixed with trig. There's not much we can do there. This is not a fraction, so it's not going to be an inverse trig. So this means we're going to have to use u substitution. Is there an inside and an outside? Yes, we have the inside of cosine. So that would be where I would start for u. Let u equal e to the 3x minus 5. That makes du equal to 3e to the 3x dx. And this is 2 times 3e to the 3x. So we just have that constant multiplier of 2 that we can pull out. And that's going to leave us with just cosine of u du. And I will let you finish that one on your own. The last two are definite integrals, but that does not change the process really any, except for maybe having to consider your limits of integration. So for number 11, not a basic rule, no way to rewrite it. You could FOIL out the 4x squared plus 4 squared, but that still isn't going to really get us anywhere. So then we look at inverse trig. No, because of the squared in the denominator. So we're on to u substitution. There's a clear inside and outside here. We have the 4x squared plus 4 that is inside the squared bit. So we want to let u equal 4x squared plus 4. That makes du equal to 8x dx. Also, because this is a definite integral, we've got to change our limits of integration. So u of 1 is going to be 4 plus 4, which is 8. And u of 0 is 0 plus 4, which is 4. So when we set this up, we have the integral from, not 0, 4 to 8. And this is another case where 24 is 3 times 8. So we can pull the 3 out. And we have 1 over u squared du. Now, what I saw from a lot of people on the last test was using a log rule here. And since this is a u squared, natural log does not apply here. This is in fact a power rule. So instead, we need to think about this as u to the negative 2. So we have 3 times our bracket notation, because we're going to move to the definite fundamental theorem of calculus evaluation here. So if we add 1, we get u to the negative 1, and then we divide by negative 1, which makes this negative from 4 to 8. So this gives us 3 times f of b minus f of a. So this is going to be negative 1 over 8 minus negative, so it becomes positive, 1 over 4. And the answer is 3/8. Do not forget this step. A lot of you are forgetting that when you're doing these integrals. Last one, I promise. So we want the integral from 1 to 3 of this example here. So is it a basic rule? No. 2, can we rewrite? Yes, we are dividing by a monomial. So once again, there's 2 different ways you can think about this. Break it apart with a common denominator. So that's x squared over x cubed plus x over x cubed minus 5 over x cubed dx. That's one way to think about it. Or you could rewrite this as x squared plus x minus 5 times x to the negative 3 dx. Either way, you're going to end up with the same place. You either distribute this here or you divide all of these out. So x squared divided by x to the third, that gives us x to the negative 1 when we subtract the exponents, plus x to the negative 2 minus 5x to the negative 3 dx. That's the same thing you get if you distribute. From here, this is just power rule. So now it's a basic rule. Again, a lot of people are trying to use u substitution at this point. And remember, really, we want to treat this as 3 separate integrals. Just work it one term at a time, and you'll get your answer there at the end. So that is going to be it for these examples. As I mentioned, I would strongly suggest that you open up the PDF that has way more detailed notes and that you consider making flashcards the way that I described at the beginning of the first video. And so that is where we will stop. And now you have some practice to do on your homework.